Metzig, who's from the Queen Mary University of London, who's going to talk about enhancing social interactions in music streaming. So thank you very much.
Okay. Hello. I present this work that is mainly the work of my colleague Alo Allik and Florian Thalmann, and I have done a part of it as well. And we are exploring the question how we can enhance social interactions in music streaming. So the questions we are interested in, we want to explore is how do people explore and select music? What kind of interfaces are they presented? How these interfaces affect the way their selection? And how we can make music discovery more collaborative and enrich the sharing experience. Mostly the standard methods are that the interfaces have like playlists, and the tracks have metadata, like is structured in metadata, albums and artists and so on, and also some higher level data like popularity, genre or mood. And we are looking more at alternatives such as networks of songs, clusters and scatter plots, and then those can be done with different ways of computing different similarity measures depending what you're interested in. In this presentation, I focus on MOODPLAY. It is a data set where the tracks, they are scattered on a plane just like this. Each dot is a track, and they have two-dimensional mood coordinates, valence and arousal. So from the left to the right, the valence is from negative to positive, and from bottom to top, it's the arousal, which is from calm to excited. And they have mood, these mood variables, they come from the website Last.fm from human annotations. And then there's a method to compute those two-dimensional mood tags from them. And it has 10,000 tracks. These moods, they can be grouped into regions. Here you see like the names are scary, angry, and then party, upbeat, mellow, slow, depending on these two coordinates. And that is the underlying how you can select music on this MOODPLAY. Here's how it looks like. The user has this interface that is this plane, and we have these mood tags and the data, and the streaming comes from the service Deezer. So I present here three different methods that we explore in this work. One is the social interaction to vote for music, where each user selects a preferred location in this mood space. And then the user preferences are displayed by their names on this plane. And you can vote, and your vote counts for a certain time and before it disappears. And you can only vote once, and until this has disappeared. And so on the plane there is an average mood that changes depending on who is voting, and there's a cursor, and that cursor will then play the music. That's how it looks like. Some of you have seen this. There was a demo about the same yesterday, and some have played around with it. So this cursor is moving around in a direction where the average mood is. And then the tracks are played that are behind there. Then the second option, so we have also implemented that if not enough people are using it at the moment, some bots appear that vote also, so that it keeps playing even if you stop voting. But as soon as someone votes, there's no artificial bots voting, it's only the humans. Another option is to have a private party, and the goal is that you don't want to be sharing music with people you don't even know and you might not have the same taste. And then you can make your own party and invite people that you want to share music with. And then the system works again the same, that you vote and like on this plane, except that you control who is on this in this party. And then the third option is that people can upload themselves tracks and they get added to their own private party. But the only caveat is that you don't have the mood text for any given song. And so here I present this algorithm, how to calculate where a song would sit if you want to attribute a mood to it. So of course, one option would be just to do it manually, like decide yourself what you think. But what we did here is they are added to, we extract features from the whole data set and calculate so high and low level features with the WAMP plugins. They look like, here's two examples, all sorts. And then from those, I calculate some summary statistics, such as like the moments, autocorrelation, but also entropy, and then also at different levels of resolution, such that you can map each song into a vector. And then on this plane, I trained a random forest classifier to identify, in the first place, how well it is possible to predict the mood, depending from those extracted features and statistics. And in the second place, because this gives me insight which are the informative features. And then I can use those to calculate the mood for songs that I don't know it yet. So I trained a classifier and on the 4 like corners, and it's relatively well possible. And then here are the importances for the prediction of arousal. So the gray is always the random forest importance, and then in the front you see two colored bars that are the two means of the two groups, how well they separate. And then in diagonal, that's the title of the plugin and of the statistics that are informative. So the most important to predict arousal is the average onset rate, which is not really a surprise. And then I did the same with another feature selection for the second variable, for the valence. And there the most important is the skewness of the spectral flux, so how fast the power spectrum changes and the skewness thereof. And so these are the importances. And you see like how it would go on, like I'm extracting 100, I'm calculating this for 100 features out of 400 that I use in total. And then you have those informative features, and with them you calculate the mood tag for new songs in the way that you use only the most informative ones to have less noise, because otherwise it's just too much data. Separate for valence and arousal. And in that space, I calculated an Euclidean distance of a given track I want to upload to all others. And then I pick the nearest neighbors with the Euclidean distance and use the average mood of the nearest neighbors in terms of valence and arousal, and that's the mood I attribute to a song. So in that way you can include new songs. And then another feature that this website has, it mixes the songs automatically into one another. So when this cursor is moving around on the MOODPLAY plane, there is an algorithm that mixes them automatically into each other. So I have not done this part, so I can't explain it in detail. So there is like an auto DJ node module, and it finds the most appropriate transition between two tracks. And it does this by using a decision tree based on audio descriptors like tempo, key, regularity, dynamicity, and then the ratio of that between the tracks. And it infers this from feature data extracted in the browser using piper.js. So that's how it looks like. You have the S1 and S2, like the yellowish and the green, and they have all these features, and then you make, depending on them, you create a transition, the M, recombining elements of the two tracks. And this and then constraints define the crossroads or effects. So this is how such a decision tree looks like. You first ask, do they have regular beats, yes or no, and then further question, tempo ratio close to 1, or tempo ratio close to an integer, and or harmonically similar, and then you come up with different ways of mixing them into one another. And who has been yesterday at the demo might have seen this. Okay, so here are the MOODPLAY is open source. Here are some links if anyone wants to play around. The first is like the website that I showed yesterday, and for the auto DJ there's also this website. Yeah, so that was what I wanted to present. If you have questions, Alo and Florian did a big part of it. You can also contact them. They unfortunately couldn't make it here. Thank you.
Thanks very much. I'd just like to apologise. I messed up on the timing of that. So sorry, it was my fault. I messed up on the timing of that. So you have plenty of time. So are there any questions? We've got loads of time for questions. Okay, I have a question for you there.
Yeah.
So the choice of music, people use music to either reflect or change their mood. Do you kind of find that, so for example, if you're looking for sad music, it might be because you're feeling that way, or it might be that you want music to change how you're feeling. How does that get reflected in this?
I mean, it doesn't really address this in particular. It's just, I think here the way it's presented here, it's like it uses the mood as a proxy for your taste somehow. And you can choose, depending on your mood, you can choose what kind of music you want to listen to, but we haven't explored the interaction with the user or what effect it has on the user. But it could probably be done with this website somehow. Yeah.
Are there any other questions? Yes.
What music library are you using?
So these MOODPLAY tags, we have the mood variables for 10,000 tracks, and they get played from the previews from Deezer, and they only play always 15 seconds and then mix them into one another.
Okay. Any more questions? Right, you've been let off lightly then. Thank you very much, Cornelia.